Hi, Year 12. I thought this would be the easiest way of giving you some feedback on the answers that you completed yesterday. I think that was done to a reasonable standard, but there's still a couple of mistakes, so I thought they were worth going over. So this first one over here, I've drawn on the line here for 1500. So everything to the right here, there's loads and loads of some peaks here, and if I had access to a database, you could probably assign what these different peaks were, but I don't have access to that database, so this is just the fingerprint region. We can't get anything useful from this. That leaves us with two notable things on the left hand side. So this first one here, this one is about just over 1700, so about 1720, so that is very distinctly a carbonyl peak, so we know it's got that CO double bond. Now what some people have made the mistake that they've misassigned this as an OH peak. This is not an OH peak. This is a CH, so there's a CH bonds. Now, if you were just using the data table, that would be a reasonable assignment to make, would be that as an OH, because it corresponds to the OH of a carboxylic acid if all you look at is the wave number. But you should know that a carboxylic acid OH is very broad, and it's usually a bit stronger as well. It would normally go further down. So if it was a carboxylic acid OH, then it would be going all the way down and round, forming something a V shape and very, very wide. Now if we look directly below, this is what the OH of a carboxylic acid looks like. So this is the OH of a carboxylic acid. So that's everything we can get from this. So this is likely is going to be either a ketone or an aldehyde. Now over to the second one over here. So we've got the 1500, so all of this stuff over here is just the fingerprint region. So not useful to us. Over here we've got the sort of U-shaped OH of an alcohol. So it's this peak here, centered around 3300, slightly higher, this about 3350. This here, those are CHs. So that's all we can get usage from here. We can see an OH group is present, no other useful functional group, so this is probably just some sort of alcohol, but we can't tell what alcohol. It could be methanol, ethanol, propanol, some sort of branched alcohol. We cannot tell. So this one down here, we've already identified the OH of an acid. Moving over to the right, 1500 is 1, 2, 3. So the only useful peak we can see is this one here. Very strong, generally pretty thin. It's the carbonyl, and it's what we expected to pair with the OH of the acid. So this is some sort of carboxylic acid. I can't tell which one. If I had access to a database, I'd be able to match up these peaks in the fingerprint region. I'd be able to identify which exact carboxylic acid it is. So is it ethanoic, propanoic, butanoic? And then the last one over here. So well done to the guys that identified this as the NH2. This was misinterpreted as the OH of an alcohol again. This is just CHs. So multiple different CHs, all sort of overlapping with each other, is why it gives a messy peak like this. 1500. This you don't need to focus on. What I think this normally is often water that's contaminating the sample, gives a peak here. I may be talking complete rubbish there, but if I remember correctly, that's what that is. But it's not one of our characteristic peaks. It's in the range where it could maybe be a carbon-carbon double bond. So that is not necessarily a bad assignment to make if you're just using the data sheet. But it's very obviously not an alkene or a CC double bond, as the CC double bond would be much, much sharper. It would look in the sense that this peak over here is very sharp. However, it wouldn't go anywhere near as far down. It would only be down. It might be as strong as this one, so get down only about this far, but it would be very, very sharp and pointy, like this one over here.